Welcome to our competency-based question series designed specifically to enhance your conceptual learning and understanding. An LCR circuit is connected to an AC voltage with fixed value Vmax and fixed angular frequency. The current through the circuit is Imax and the resistance R equals the inductive reactance XL in the circuit. So let's draw the circuit. We are having an RLC circuit which is connected to an AC supply. The value of R, it is equal to the value of XL. So XL, it is equal to R. But we don't know anything about the capacitive reactance. So let's find out the value of impedance for this circuit. So initially, Z, it is equal to under root of R square plus XL minus XC whole square. And in place of XL, I can write R. So it will be R square plus R minus XC whole square. That is the value of Z. And we can also find Imax. That is equal to Vmax divided by Z. In the later part of the question, we are changing the distance of separation between the capacitor plates as 2t. So we know C is equal to epsilon naught A by T. And the new capacitance C dash, it will be epsilon naught A divided by 2t. So when we are increasing the value of separation between the plates D, C will now be reduced. So this implies this thing that C dash, it is equal to C by 2. So we can make the circuit R, L, and it is C dash, that is equal to C by 2. And they all are connected to an AC source with maximum voltage Vmax. And again, XL, it is equal to R only. Since the value of capacitance is decreased, there is a change in the value of capacitive reactance as well. We know the value of capacitive reactance, Xc, it is equal to 1 upon omega C. And now this C is reduced to C by 2. So Xc will increase. They are inversely proportional. So there is a decrease in C that will lead to the increase in Xc. So Xc dash, it will become equal to twice of Xc. Again, we can write the value for the impedance Z dash, that is equal to R square plus XL minus XC dash square. So it will be equal to under root of R square plus XL is R minus twice of XC whole square. So that is the value of Z dash. And again, we can write the value for Imax, but in this case, Imax is reduced to half. It is given in the question that when the capacitor plate separation is doubled, the current Imax in the circuit is reduced to half. So we can write Imax divided by 2, that is equal to Vmax divided by Z dash. So this was my equation 1 and this was my equation 2. So we can divide these two equations. So if I write Imax divided by Imax upon 2, that is equal to Vmax by Z divided by Vmax by Z dash. So this Imax get cancelled out with this Imax and 2 will move in the numerator. So this will imply 2 is equal to Z dash upon Z. So this is the relation between the two impedances. And now we have to find the relation between R and Xc, that is resistance and capacitive reactance Xc. So let's use this equation in order to find the relation. So we can write 2 is equal to Z dash upon Z. So if we can square them, 4 is equal to Z dash square divided by Z square. And we know the value of Z dash square. It was R square plus XL minus XC dash square. That is R square plus R minus twice of XC square. So we can write R square plus XL minus twice of XC whole square divided by R square plus XL minus XC whole square. And this XL, it was equal to R. So further we can reduce it to as 4 is equal to R square plus R minus twice of XC whole square divided by R square plus R minus XC whole square. So now we can first open this bracket A minus B whole square, and then we can multiply with 4 using the cross multiplication. So that can be written as R square plus 4XC square minus 4R times XC divided by R square plus XC square minus 2 times R into XC. So now we can further reduce it as R square plus R square will become 2R square. 2R square plus 4 times XC square minus 4R XC divided by 2 times R square plus R square again 2R square plus XC square minus twice of R multiplied by XC. We can cross multiply it. So this will be equal to 8R square. 4 into 2 is 8R square plus 4XC square minus 8 times R multiplied by XC, that is equal to 2R square plus 4 times XC square minus 4R XC. So this gets cancelled out with this, and we can take R towards one side and R multiplied by XC towards one side. So it will be 8R square minus 2R square will be 6R square. That will be equal to, and this minus 8R XC, it will move towards this side. So minus 8 times R XC will be equal to, on adding with this, it will become 4R XC. So 4R XC. So one R gets cancelled out with this, and we are left with 6R divided by 4, that is equal to XC. So further we can solve it as 3 upon 2R is equal to XC, or we can write R that is equal to 2 by 3 times of XC. So this is the initial relationship between the resistance R and capacitive reactance XC. Thank you. Keep learning, keep practicing, keep excelling.